Standard 7.G.2. This standard is about unique triangles. So it's about determining what makes a triangle unique, where there's no other way to draw that triangle. Problem number 6. An isosceles triangle has two sides with length 7 feet and two angles with measure 55 degrees. How many distinct triangles can you draw with these restrictions? And so there's only one that you could draw. Anytime it says distinct for one thing, that really is talking about, is it unique, is it distinct? That's about the same thing. And if you have two or more sides of a triangle given, then it will always be unique. If it's an actual triangle and you know at least two sides, it will be unique, because the third side will have to be will have to create a triangle. And we actually do know a couple of angle measures, but the angle measures have very little to do with whether it's unique or not. We're really looking at the sides. Problem number 7. How many distinct triangles can you draw which have one angle measuring 34 degrees, one angle measuring 69 degrees, and one angle measuring 77 degrees? Well, this triangle could be very small with these same angle measures, or this same triangle with those angle measures could be very large. So you could have this 77 degree, 69 degree, and 34 degree. No matter what size triangle you're drawing, you could even make it a much larger triangle. So there's an infinite number of possible triangles that could have those angle measures. We could check it and see, is it a triangle? Although we do know if it is a triangle, there's an infinite number. But do 34 plus 69 plus 77 add up to 180 degrees? And so we would add those together, and they do add up to 180 degrees. So yes, it is a triangle, but it's not unique. Number 8, how many distinct triangles can you draw which have one side length of 3 centimeters, one side length of 6 centimeters, and one side length of 7 centimeters? Well, we can test this. We can add the two smaller sides, and that's got to be greater than the longest side. So we have 3, 6, and 7. So if I add 3 plus 6, is it greater than 7? That's just deciding, is it a triangle? And it is. So yes, it's a triangle. And then we have to decide if it's unique. And it is unique. And one way we know this is because if I draw those three sides, 3, 6, and 7, I can't draw that larger or smaller. Those are the side measures, so the size does not change. So there's only one way to draw that triangle. Number 13, how many unique triangles can be drawn with side lengths 7, 6, and 15? Well, let's just determine if it's a triangle first. So let's take the two shorter sides, 7, and add 6 and 7 together, and see if it's greater than 15. We get 13 is greater than 15. That's false. So this is not, or isn't, a triangle. So 0. Standard 7.G.5 is all about angles. Looking at this first problem, select the term that tells how each pair of angles is related. So if I start with this angle 1, notice that this is part of a pair of parallel lines cut by a transversal line, and that forms two angle measures. So there's just two angle measures throughout this entire diagram. So this angle 1 and angle 3 are congruent because they're vertical angles. Angle 5 is congruent to angle 1 because they're corresponding angles. Angle 7 is congruent to angle 5 because they're vertical angles. And so these will all be equal to each other. So angles 1 and 7 are congruent. These others we're going to have to look at just a moment. Let's see. Now angle 2 and angle 4 are congruent. Angle 2 and 6 are congruent. Angle 6 and 8 are congruent. So angles 4 and 6 are congruent to each other. They're all obtuse angles and they'll all have the same measure. Now if we start pairing some together, say angles 2 and 5, well, 2 is this obtuse angle and 5 is this acute angle, but if we moved angle 2 beside angle 5, they add up to 180 degrees, so they're supplementary. And angles 3 and 8 are also supplementary. Number 2, if the measure of angle DAC is x, and the measure of angle CAB is 2x minus 30, what's the value of x? Well, to get x, we need to set up a relationship between these two angles. And right off the bat, you notice that they have this 90-degree angle in common. And so I'm going to set them in an equation by saying 2x minus 30 plus x adds up to 90. And we'll just go through and simplify. 2x plus x is 3x minus 30 equal 90. And then we want to get 3x by itself. So we're going to add 30 to both sides. And 3x is equal to 120. Divide both sides by 3. And x is 40. It's just asking for the value of x, so we finish there. Sometimes it goes beyond and asks for one of the angle measures. Number 5, what's the value of x in the figure shown? So this is what we have that has an expression that includes x. And we just look for some angle relationship that we could use to solve for x. And what I notice is I know this angle here, 37 degrees. I know that that's formed by two intersecting lines, which means that these are vertical angles. So if I take 3x plus 1, it's equal to 37 degrees. So I'll just simplify this. I'm going to subtract 1 from both sides of the equation to get 3x equals 36. Divide both sides by 3, and x is 12. And that's all it's asking for is the value of x, so we would just mark that. Problem number 6 says in the figure shown in item 5, what's the value of y? So we want to know this value of y. What we do know is that y plus 37 is equal to 180 degrees. And that's because they are supplementary. They form a straight angle. So when I subtract 37 from both sides, I get that y is equal to 143 degrees.